Hello, this is Shay, Akai Custom Guns. Want to talk a little bit about compensators. The goal behind this video is to be as short as possible, educate you as much as possible, or at least express my opinion as much as possible. This is, again, my opinion. Other people's opinions, of course, vary. The whole concept behind a compensator, this is an open gun. This is a MIDI. It's actually a short MIDI. It's basically a commander slide. This is our compensators. This is one of our newer compensators. And we want to talk about the goal behind it. Basically, the way open guns are designed, we run very gassy loads, lots and lots of grains, lots and lots of gas, and that is in order to make the best use out of the compensator. The compensator has two schools of thought. There is a school of thought that says that the compensator is meant as a muzzle brake. A muzzle brake, basically, if the gun recoils this way, the compensator pulls the gun this way, so it kind of negates this kind of action in the gun. There's another school of thought that says that the compensator is supposed to press down, so eliminate the muzzle flip. Now, in order to eliminate the muzzle flip, you have to have up ports. I'll give you an example of that. If you look at a compensator such as this, has lots and lots of up ports. This one has lots of up ports. This one has a lot of up ports. This one has a lot of up ports. The thing about it is, as far as I'm concerned, the longer the gun, the less you want the up and down pressure. And the reason why is because if this is your gun, and imagine it much, much longer, and if you press down over here every time you shoot, the hands actually go like this, and the gun starts doing this. Because every time you shoot, it presses down, and the gun is doing this. As far as muzzle brake is concerned, yes, it's extremely important. But because this is a recoil-operated firearm, if you eliminate too much of the recoil by putting too large of a muzzle brake or too efficient of a muzzle brake, the gun won't open, the gun won't function. So we're always walking a balance between the most efficient muzzle brake we can possibly put on it and not too efficient to where the gun is not working. What we did at Akai Custom Gun basically is we took all these compensators and we tested all of them. And one of the lucky parts behind what we do is we get to repair a lot of guns, we get to look at a lot of guns, we get to shoot a lot of guns, and we've had a whole plethora of compensated guns coming through here, and we have arrived at a few conclusions. These are, I mean, they're beautiful, and they work great for their purpose. And of course, I mean, I had a lot more of them that we tested. But what we found is that they put too much down pressure. And the other thing behind them is that they don't equalize the pressure. One of the things that most people don't realize as far as compensators are concerned is when the gas actually comes out of the barrel, it's twisting. And when the gun is twisting, I'm sorry, the gas is twisting, it's not even coming out. This is a compensator that the ports are pointing forward, for example, so it's pressing down a little bit. These bleed a lot more than straight up and down ports like this one. This one's still pointing forward just a little bit. It's starting pointing forward and then they get even, but they bleed a lot more. This is another type of compensator where the ports are actually pointing back. And by pointing back, it's putting more of a jet effect back, and it's acting like a muzzle brake, more of a muzzle brake. Again, you know, compensator works great, but it does nothing for stability. This is our old compensator, and our old compensator worked great. Of course, it got copied, but it works great. You have a small port, a large port, and a huge bleeder port. And here's the philosophy behind it. I'll explain ours. I don't speak badly about any other company. I just don't do that. I can speak about us. As the volume of the gas decreases, it needs more time to come out. So you have high volume, high pressure, lower volume, lower pressure. So the higher volume needs a smaller port, and the higher pressure, the lower pressure, lower volume needs more time to exit. This way we even out the exit of the gases so they're not abrupt. If you look at other compensators that are progressively smaller, The first main port does all the work, and then less and less and less and less and less. We want even. Even creates a very, very stable dot. This huge bleeder port is extremely important. Basically, there are forces that most people forget about bullets. Bullets have either a flat back, or they have a concave back. Now, what that does is it actually creates a suction force behind the bullet, and as it sucks gases behind it, a lot of gases follow the bullet out. If you look at a compensator like this, and I'm not speaking badly about the compensator at all, but there's nothing to really release the suction behind the bullet. What you end up having is you end up having a bullet coming out of the compensator with lots and lots of gases behind it. The whole goal behind the compensator, the best test for a compensator, is to have the gun, the gun, and put a piece of cardboard about this far away from the gun and shoot it. If the cardboard gets blown away, that means that there's way too much gases coming out of the last port. If you are not using all of your gas, if gases come out, then it's not efficient enough. Our goal is just the bullet to come out. We don't want any gases coming behind it. We want to use 100% of the gas. We want just the bullet to come out. In order to do that, we put a very, very large port, very large bleeder port. And what it does, it creates some kind of a gap or a stop. It's the same thing if you're driving down the highway and you are behind a semi. You're drifting behind a semi. The semi is actually sucking you behind it. As it's sucking you behind it, you can let your foot off the gas, and it's basically carrying you forward. The moment that you break away from the semi, the moment that you do this, you're forced with all of this air, and you can go forward. But what's carrying you behind the semi is the suction force. The vacuum force is actually more powerful than the resistance force. The reason why we create this one is to let that little burst go, so we strip all the gases from the bullet and only the bullet exits. Now, the way we develop compensators is we go on the lathe and we make blanks. These are blanks, and I make them by hand on the lathe. And then we cut all kinds of funky, different designs. And we actually have a lot more of them. And we play with all the ports. And then we go to the range. You can see all of them. All kinds of different designs. And we go to the range and we basically test them all. We bring a gun and we screw the compensator on and we shoot a couple mags through it. Okay, these conclusions. We come back to the shop, we do it over. We come back to the shop, we do it over until we actually have a design that we really, really like. Our newest compensator, basically this one, has a completely different concept than other compensators out there. We have a huge expansion port. The expansion port is extremely important. It's the same thing as a two-cycle exhaust. It allows the gases to go into a large chamber, even out, equalize. The thing about it is when a bullet goes through a barrel, there's rifling, and the rifling creates a twist in the gases. Now, in order to even out that twist, because compensators like this or like this don't have a way to even out the twist, we have a large expansion chamber. What happens with a twist is you get a cocking action in your gun. This compensator has a large expansion port that evens out those gases. Now, we vent out these gases in a backwards 45 degrees. It's actually not 45 degrees, but it's being vented in a V shape out. The reason why is so nothing gets in your line of sight. If you look at other compensators, and again, I'm not knocking anybody's compensator, but if you're looking at any compensator with up and down ports, all the fire, all the gases go straight up. And this is what you're trying to look through. So people end up flinching. I don't want people to flinch. I want people to be able to see the target as well as possible, and this is where this compensator comes in. The gases get vented this way, and there's nothing in your line of sight. They get vented back, so it actually pulls the gun forward, plus it strips all the gas off the bullet. Now, this is one of the original versions. We now have, of course, this version. which the ports are actually angled forward a little bit and back. And this one is even more efficient. Of course, we also make them out of titanium. This is one I made by hand as a prototype, out of titanium, so less weight up front. The whole goal behind a compensator is a stable dot. You want a stable dot, and you want the bullet to exit as cleanly as possible. If you want to test your own compensator, have as neutral of a grip as possible. Watch your dot, see what it does. If the dot is doing a figure 8, that's not good. If the dot is going straight up and down, that's what you want. You want to be able to call your shots. You want a shot, dot goes up, and then you take your second shot. If it's got any kind of twist to one side or the other, then that's not good. If too much gas is coming out of the front hole, that's not good. Let me see if there's anything else I want to cover. Yes, there's a way to make a gun overly flat. If this is one of the complaints about this compensator, the gun was overly flat, and this is my opinion. It's a little controversial. You know, a lot of people argue with me about this, but if the gun is overly flat, then you have a problem, because you take your first shot, and then the dot just jitters, and then you take your second shot, your follow-up shot, but because the gun really didn't move, you were not able to track the dot. The gun just jitters. You have no idea where your second shot is. What happens is you have Alpha Charlie, Alpha Charlie, Alpha Charlie, Alpha Charlie. What I want is I want snake eyes. I want the second shot to be an inch away from the first shot. In order to accomplish that, you need a compensator that actually stabilizes the dot. Stabilizing the dot, causing a little bit of a muzzle flip, enough to where the dot goes up, let's say halfway through the A zone, and comes back down, you're able to call your second shot. If the dot never moved, or the dot just jiggled, you have no idea where your second shot is, and that's where you end up with lots of Charlies. And lots of Charlies is no good. The whole goal behind our compensator is to give you as many snake eyes as possible. If you can take 2 quick shots and you get snake eyes, that's what you want. If you do 2 quick shots at a match and snake eyes, snake eyes, snake eyes, if the RO has to come up to you and do and call doubles all the time, that means that you have the ultimate compensator, or your gun is tuned correctly, of course. We're going to do other videos. We're going to do videos about frames, about grips, about everything like that, so stay tuned. But this is a really, really quick video about the process that we go through. If you have any questions whatsoever, you know, let me know. Comment and let me know, and we'll go from there. As far as patents are concerned, there's people that copy compensators, and it, lack of better language, pisses me off. There's lots of work that goes into developing a compensator, lots of testing, lots of load testing, lots of back and forth to the range. I don't believe in fluid models. I don't believe in gas models, because every gun is individual, and the action of a gun, the temperature, the pressure, the time that the pressure curve is completely different than any model can actually copy. So the only way to develop a compensator is back and forth to the range. If you copy compensator, I'm sorry, but you suck. The reason why is because we have so much work into it. Our compensators get copied. Lots of compensators get copied. If somebody copies our current compensator, we're just going to come up with a new one. That's about it. Thank you for watching.